We're going to be starting a whole new unit, and it is called functions. Our goal at the end of this lesson today is to determine if a relation is a function or not a function. A relation is just a set of numbers with inputs and outputs. So a function is defined by a set of numbers or relation that each input has exactly one output. So we need to clear a few things up. First, an input are x values. It's what we plug into the expression. The output is the y values, which is the result. So if I look at my first function, if I plug in 2, so that is my input, I get out 5 because 2 times 2 plus 1 is 5. If I plug in 3, my output is 7 because 2 times 3 plus 1 is 7. If I plug in 4, I get out 9. To be a function, x has to have exactly one output. That means every single time I plug in 2 times 2 plus 1, I will get out 5. We're going to be analyzing sets of data, just like the table I created, to make sure that the x value is special. That's what makes it a function. This also works for squaring. So if I have an input of 1, 1 times 1, or 1 squared is 1. If I have an input of -1, -1 times -1 is +1. This is still a function because x has a special relationship. Every single time I plug in 1, I get out 1. Every single time I plug in -1, I get out 1. It is okay for the y values or the outputs to repeat. It is not okay for the x values to repeat. So we're going to analyze a few different models. So the first thing we're going to analyze is a table. The table on the left is a function because x has only one output. So every single time I plug in 1, I get it out 2. When I plug in 2, I get out 4. When I plug in 3, the result is 6, and so on. On the right, we have a non-function with this set of data. It is a non-function because I can't plug in 1 for an input and get a result of 2, plug it in again and get a result of 5. This is an error in the function or a break in the function. So because of the input of 1 resulting in 2 different outputs, we say it's a non-function. We can analyze data as ordered pairs. So if I plug in 4, the data says I'm getting out 12, 5 results in 15, 6 in 18, 7 to 21, 8 to 24. There's no repeat in the x value, so that is a function. If I look at my set of non-functions, I actually have 2 numbers that break the rule. I am not allowed to plug in 4 and get out 12, plug in 4 again and get out 15. This is a break in the function. It is also a break in the rules with 5. I can't plug in 5 and get out 18, plug it in again and get out 21. So this is a non-function because my 4 repeats as an x value and so does 5. Our next diagram, we're looking to see if x repeats. So this is my input or my x values on the left, and on my right is my output or my y values. So -3 is paired up with 1 output. -2 has 1 output. -1 has 1 output. 0 has 1 output. 1 has 1 output. So this is considered a function. On the right-hand side, however, my input repeats, and it repeats for 1. I can't input 1 and get out 0, and then input 1 again and get out 15. So 1 is where my break in the function exists. The last set of data that we're going to look at is a graph. So we can also use the vertical line test in order to determine if a graph is a function or a non-function. So if I draw a vertical line, it should only pass through the graph one time. So anywhere I draw this line, it only passes once. So that means that x has exactly one output. Anywhere I look to find what my x value is, I only have one output. So this is a function. Unlike graph number 2, if I were to draw my vertical line multiple places, it is a break in the rule. It crosses through twice, multiple times, which means if I were to find if x is 7, there are two different outputs. Way up here at 7, way down here around -7. So this is a non-function.